So this is to show you how to find critical values using Statcrunch. So given a level of significance, I can find the critical values using Statcrunch. Remember, the level of significance gives us the area or areas in the tails of the distribution. And I would like to know what the cutoff points are for that tail or tails to determine my critical points. So I'm just going to use calculator, normal, and if I'm using the Z distribution, what I'm looking at, let's say we're doing a right-handed test with significance level of 0.01. That means that the area in the tail would be 0.01 in the right tail. Remember, this is Z. So I want to find the Z critical for which the area to the right is 0.01. So over here, I'm in my standard normal. What I'm doing is it's a greater than because it's a right-handed test. Take that out because I'm looking for the critical value. And the area, right now it shows a value of 0.5. I want this to be 0.01, I believe is what I said. So my Z statistic is then this number right here, 2.32. Rounded up is 2.33. Okay. If I wanted to check a left-handed or left-tailed distribution with the same level of significance, 0.01, it should be symmetric. So I have 2.326 to the right and minus 2.326 to the left. So with my left distribution, Z critical, this is what we're looking for. Even though that says X, we know it's a normal distribution. We're dealing with Z's. And this area is 0.01. Okay. I can also check it for really any level of significance. I mean, the most common are 0.01, 0.05, 0.10. So let's see, if I wanted to check to the right for 0.10, it's 1.28. Now notice as the area becomes larger, the critical values tend towards the mean. Okay. I can also do a two-tailed test. Let me take these out right here because we don't have the data yet. So two-tailed test would be a between test. Now say I wanted to test at the 0.05 significance level. So alpha equals 0.05. What this means, my standard normal distribution, is that half of the area of that significance is in the right tail and half is in the left tail. So that's because this is 0. Our mean is 0. Oh dear. Let me try that again. Our mean is 0. We have a significance level of, I think I said 0.05. So half of that area is in the right tail here, and half of the area is in the left tail. Here. So half of that area is point alpha over 2 is equal to 0.025. Okay, so this is just a little tricky, but not too tricky. So if I'm doing the between, well, let me get rid of this right here, right? If my significance level is 0.05, then the area between those two critical statistics, critical z's, is 0.95. So I come up with 1.96 to the right over here and minus 1.96 to the left over here. We're not counting this area. We're actually interested in the area in the tail, but that's indifferent to this. It is the cutoff point. So we can do the same with the t statistic to find the critical values of t. You can use the tables, but you don't really need to. Okay, so I'm going to go to the standard. And if I'm doing, make sure that's standard, yes, a left-tailed test at the 0.01 level, extra decimal point there, I would have to know my sample size. Okay, so if it starts with degrees of freedom of 10, if I had 20 observations, my degrees of freedom would be 19. So degrees of freedom is n, or the number of observations minus 1. And so my critical value of t at the 0.01 significance level for this sample is minus 2.539, minus 2.54. Okay, let's just try that for 10. And when I say 0.0, let's try that for 0.05, and it's minus 1.81. So it squeezes it in a little bit as we towards the mean as our sample size is smaller. Okay, if I wanted to do a right-handed critical value computation, let's say 0.01, and my degrees of freedom are 19. I get 2.539, 2.54. Let's try this for 10, and it's 2.763. I can also do a between, so let me clear these out. With 10 degrees of freedom, again, you need to know your sample size. I'll be given the degrees of freedom. Your significance level, let's say, is 0.10. Again, these should be the same, but I'm going to put in 0.9 because it's a between. Oops, too many decimal points. Okay, so minus 1.81 and plus 1.81 are the cutoff points. Okay, so when we're doing this, you want to take 1 minus the significance level to put in the area here to get the critical values. And let's say degrees of freedom is 19, and we're at the 0.05 significance level, so this would be 0.95. So my two critical values are minus 2.093 and plus 2.093. So again, although we're interested in the area and the tail, ultimately, it's the critical values that we're looking for to start, so that you don't have to go and use the table.